So rule number 3. So that's rule number 2. So rule number 3. Rule number 3 here we take into consideration depends on the substitute in the organic compound. So I'm going to give you the various substituent and the substituent names. So yeah, let's choose substitute. Means of substitute. Chlorine, bromine, OH, amino, methyl, ethyl, propyl, propyl, so perhaps fluoro, bromo, azo, fluoro, bromo, hydroxyl, amino, methyl, ethyl, propyl, iodo, cyano. So these are the major substituents and the substituent names. So let's take a case where we have a compound with one of the substituents. So let's take the case of this compound. We have CP, CH, Br, CT. So when living an organic compound, all the rules of nomenclature are applicable. So let's start by counting. So here I'll just let the area, but after I will tell you why the let them is done here. So let me just let it. 1, 2, 3. A bromo group is on position 2. That's why we say 2 bromo. Open. 2 bromo. Open the blood, the organic compound is having 3 carbon. First, a case where organic compound is having more than 3 carbon. CH2, CH, chloro, CH2, 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 R. Yellow is very, very dangerous. If we just name like a robot, a dead person, you will fail tremendously. So the nomenclature is not done anyhow. So you start naming such that its substituent should have the least number of carbon. So yes, it should have the least number or the smallest number. So you start doing here 1, 2, 3, 4, 5. You see that the chloro group is on position 4. So let me try the other side. So 1, 2, 3, 4, 5. You see on the board there are 2 ways of nomenclature. One having numeral, the other one being Roman numeral. Having numeral, a chlorine is following position 4. On the other side, with Roman numeral, the chlorine is following position 2. So you judge between 4 and 2 which one is smallest. Automatically, obviously, is 2. That's why the name of the compound will be considered with a 2 nomenclature, not with a 4 nomenclature. These are the rules, the systematic rules of nomenclature. So here the compound will give us 2 global 18. 18 because the compound is having icon. So it's 2 total 18. Good. In this case now, you always put in your head the substituent should have the least number of carbon possible. Then I'm going to give you a tricky exercise. That's you people will not be. You people need a high degree of commentation to actually say the way I'm saying this. Let's give me a tricky number. See it good. See? Isso. Cinco. So this compound, the nomenclature of this compound is in the next room. It's not in this room. So the compound is, we need to look for the longest carbon skeleton. So 1, 2, 3, 4. So you guys, I told you why I started in the other side. So maybe the other sides are 1, 2. So that this substituent should fall in position 2. For the moment, I'll allow the organic compound there for them. So I'll say certain things before I come back to the organic compound. So let's go to the next group. So what number? If a compound have identical substituent, the identical substituent, the number of identical substituents will have prefixes. If there are 2, we say die. If there are 3, we say try. If there are 4, we say tetra. Okay. See what will better happen. I'm going to give you a mini table. Here I have a prefixes. If it's 2, we say die. The diet is not the same as you guys know. So some of you say die is the same as dead. It's not dead. Die in this case is 2. So 3 now is try. 4 ika. 5 eta. 6 heza. 7 hepta. 8 opta. 9 nona. N deka. Voilà. So if it's 2, we say die. If it's 3, try, tetra, pelta, hexa, hepta, opta, nona, deka. That's beautiful. So the substituents are giving this name if and only if they are identical. If they are not identical, I don't want to catch somebody say die. So if they have 3 identical substituents, say right. So let's come back down to this organic compound. So there are 2 ways of limit. So having 1, 2, 3, 4. I carry the other side. 1, 2, 3. See that I'll choose the side where the number of carbon is small or the smallest. Sorry. So here now I'm gonna have 1, 2, 3, 4. So here we'll have on position 2. I have 2 identical substitutes. So that's why we say 2, 2. This 2 is for this methyl group. This other 2 is for this methyl group. Given that they are identical, we say di methyl butan. 2 dimethyl butan. Okay, what if we come have 3 substitutes? Identical substitute. So this is organic compound. No. Organic compound is so this other organic compound of having three identical substituents, I can have CH3, C, Cl, Cl, C, Cl, H, CH2, CH2, CH3, and so the compound is having three identical substituents. Then start count. So you type counting like 1, 2, 3, 4, 5. The first substituent is calling in position T. So let's try the other sides. 1, 2. The first substituent is following in position 2. So automatically you choose 2. So let's type counting 1, 2, 3, 4, 5. So you are gonna see the chloro. In fact, here we have 3 chloro, but the chloro are not found on the same carbon. The first 2 chloro are found in position 2. The other chloro is found in position 3. That's why here I'm gonna say 2, 2, 3. Trichloro pentane. 2, 2. Because the first 2 chloro in position 2. But I have 2, 2 trichloro because of position 3 we only have 1 chloro. So 2, 2 trichloro pentane because the compound is having 5 carbon. This is in case we have identical substituent. Okay, what if we have different substituent on the organic compound? So this goes to the other rule, the presence of different substituent on the organic compound. So let's get to the next one, different substituent. If there are different substituents, we arrange the substituent in alphabetical order. Very important. If the substituents are all different, we arrange them in alphabetical order. So see what happens. Let's take the case of an organic compound that C, Cm, H, OH. Let me count the OH group. Meeting CH2, CH2, CH3. So see the organic compound, but so let's start counting 1, 2. 1, 2, 3. Automatically we start counting the lowest. So 1, 1, 2, 3, 4, 5, 6. It's a 6 carbon compound. Hexene, hexene. But on a compound we have 2 different functional groups. We have a chloro and we have a methane. We have chloro, we have methane. What should we do? We arrange the substituent in an alphabetical order. Between chloro and methyl, automatically is chloro that comes first alphabetically. Okay. So chloro automatically. So the chloros of version 2, so take 2 chloro, 3 methyl, hexane, 2 chloro, 3 methyl, hexane. So let's take a complex one now. Complex. CH3, C, CH3, O, CH, chlorine, CH2, CH3. Après, the rule or the semantic rule of the nomenclature, we here have 1, 2, 3, 4, 5. In this case, we have 3 different substituents: a bromine, a chloro, and a methyl. So what should we do? First of all, bromo. Alphabetically, it's a bromo that comes first. So here I would say 2 bromo, 3 chloro, 2 methyl, pentane, pentane. What? So the name is a bit long, so il y aura 2 bromo, 3 chloro, 2 methyl, pentane. IB 2 bromo, 3 chloro, 2 methyl, pentane. Let's have another one. One, 2, 3, 4, 5, 6, 7, 8. What? 8 carbon compound. So the identical groups, we have methyl group that are identical. So here we say 2, 2, 2, 2, 4, trimethyl, trimethyl, 3 gomo, 3 gomo, 3 chloro, octane. Voilà. C'est le nez is a bit long. So we have 2, 2, 4 trimethyl, 3 bromo, 3 chloro, octane. The identical groups are position 2, position 4. That's why I'm adding 2, 2, 4. Trimethyl, 3 bromo, because the bromo is on position 3. The chloro group is also on position 3. That's why I'm having 3 bromo, 3 chloro, octane. So let's take a small example. I'm going to give you a series of organic compounds, and together we're going to name them. So, example 1. Make the following organic compound. Name the following organic compound. So, any different element are A, B, C, S, T, B, C, C, or C. So, I'll be giving you, and together we shall be naming. I start counting. 1, 2, 3, 4. That's beautiful. Option 2 now have 2 groups, an amino group and a bromo group. Alphabetically, amino comes first. Beginning the amino comes first, we say 2 amino, 2 bromo. Begin. So let me give you an alkene compound. No. CSP, C, CSP, CSP, CH, give.
Then now you have a very big trap now here. You have the compound is an alkene. So start counting where the alkene functional group is found. We should not start counting where the substituent is found. If you have a substituent, you have the functional group. The substituent is more powerful than the functional group. Why? Because the compound before having substituent is first of all an alkene. So start here. 1, 2, 3, 4. On position 3, we have methyl groups. That's what we say. 3, 3. Dimethyl. But welcome. 3, 3. Dimethyl. But. Page 1. Okay, let me give you the other examples because we have 4 examples like this. So I've just given you 2. That's A, B. So C no. This is a C compound. A C compound is a symmetrical compound. Meaning if you turn the compound in the middle, the left hand side equals to the right hand side. Okay, let me come on. 1, 2, 3, 4. What two sort different substituent? But I have two different substituent. Alphabetically, the map 2, 3 dibromo 2, 3 dichloro. Written 2, 3 dibromo 2, 3 dichloro. Written. Why? B can before C alphabetically. So the bromo group comes before the chloro group. So that's C is to me. C. The other. Okay. C. Yes, B. C. C. No. C. I take the clicks. Okay. The group, the identical group, I mean, okay. That 3 now. So what? 2, 3, 4. So we say 2, 3, 4. Let's never be clear this exercise. Why the example? One different substitute arrange them in alphabetical order. So I'm in the bromo. If you have a bromo, the bromo campus. So you say 2 bromo. 2 bromo. 3 chloro. 2 bromo. Why the bromo go alphabetically? So bromine like a after bromine is chlorine. So I mean 2 bromo, 3 bromo, 2, 3, 4. Trimethyl hexane. Alphabetically. So put it in your heads. Alphabetically. A propo, chloro, methyl. Yes, put it down now. Bromo, chloro, methyl. Try to see that B come before C alphabetically. So bromo come before chloro, chloro come before médecine. That is why the base of organic compound is what? Subhomotrico 2, 3, 4. Trinity hexane. So now we're going to go to the next rule. The next rule now is the nomenclature. In case we have different functional groups of organic compound,